leaving the site of El Zotes, which was the capital of an ancient Maya kingdom. It wasn't a particularly large kingdom, but it did have its own dynasty. We've been working here since 2006, so this is our 11th field season out here in the Patan.
Directors of the Engineers for Exploration group. The goals of that program have sort of expanded a lot over the years, but mostly what it's doing is focusing on trying to build technology for remote sensing applications. So we have a number of different collaborations. So in the past we've worked a lot with National Geographic. We also work a lot with San Diego Zoo. We also have done a good amount of work recently in the past 2 or 3 years with archaeologists. So Tom Garrison from USC, Steve Houston from Brown. So there are 2 archaeologists that have been working at a site called El Zotes in Guatemala.
I started to work with Engineers for Exploration around the fall of 2015. I was really impressed by all the amazing projects and opportunities that they have. I started looking at 3D scanning technology, mobile scanning technologies, and how I could apply them to the Maya archaeology project particularly.
So the Maya archaeology project started in February 2014. The original idea was, can we develop a technology that can explore, can find new sites hidden still under the jungle canopy. The technology of choice was basically LiDAR. So what people currently do is they fly a LiDAR in a commercial plane, a large manned plane, fly over the jungle. Now that's expensive, and so the idea was, can we build a cheaper technology based on a cheaper LiDAR that we can fly on a drone? So that was the idea of the initial project. We also brought a fixed LiDAR with the idea of, well, we can scan the tunnels that Tom is digging at the same time.
You know, I've been collaborating with Engineers for Exploration since 2014. Our ultimate goal is to do successful aerial drone mapping using LiDAR through the jungle canopy, but we've had many successful collaborations as a result of trying to develop that technology, not least of which has been the 3-dimensional scanning of our tunneling excavations.
There's two main applications for that, I would say. One is to scan those like masks that are sculpted into the walls of the temples. Also, they want to scan the tunnel excavations, not necessarily a detailed scan, basically to make a map of the tunnels.
Archaeology, especially Maya archaeology in Guatemala, they do a lot of tunneling into the temples, and they unearth different types of things, and they want to be able to measure those tunnels and the things that are in those tunnels. So masks or steps or other artifacts of the temple that they're tunneling into. And so we've done a good amount of work on trying to create accurate 3D models of that using different types of technology.
The first technology we deployed was just LiDAR. The goal was to get a 3D point cloud of the entire tunnel system, plus all the masks. And the challenge was that basically the way you operate this system is you have to set it up on a tripod, you activate it, and it takes a scan in that particular location. Then you move it, and then you take a scan in the next location. And you need to stitch all these scans together, all these point clouds together into one consistent point cloud. So basically it took a student several months to actually create that scan. So you don't really have an idea of how good you're doing while you're in the field. We also use structures from motion, where you take a bunch of pictures of an object from different angles and you make a point cloud based on that. Really, you don't know while you're taking these pictures how good you are doing, so you don't get real-time feedback. If you don't take a picture at a certain angle that you need, the model may not be complete and you may not know that while you're in the field. The stationary LiDAR and structure from motion, they're good technologies, but can we do something better? Can we give more real-time feedback So this year the plan was to go back and actually test out these more real-time technologies.
I was really interested in looking into these mobile applications, in these mobile technologies like the Google Tango. I started to develop an application on the Google Tango. At some point we went to some nearby underground caves to test it. It was fairly promising, so we continued in that direction. We continued developing some other softwares, some software that could apply to the Kinect as well. At some point we had to decide who is going to Guatemala this year, but it turns out that this year nobody was available. Basically only I was free to go. It was a little scary at first, but exciting at the same time. Fortunately, I got a lot of advice and a lot of help from people who went to Guatemala last year and the previous years. That was my first experience with E4E, first time going in an archaeological site, and well, that was amazing.
Okay, so our first stop is El Diablo. Hiking there.
There's a lot of sort of natural, they're dangerous, but natural things that you want to be aware of, like maybe the tunnel caving in or hitting a part of the wall, for instance. These are artifacts that ideally would be preserved for many generations. Spiders everywhere. I've seen some rats in the tunnels before. I saw a snake, a big black snake in one of the tunnels. Bats as well. The heat is also pretty bad. Lighting is an issue, I think, a lot with, especially when you're trying to create the 3D models. When we take the LiDAR in there, when we come back, it's just covered in dust. With some of the other technology like the Tango or the Kinect, it's a lot easier. But just getting the actual software to do the 3D modeling is a challenge.
Okay, so I'm in El Diablo at the entrance, and I'm gonna start mapping the tunnels.
I really realized why we were doing that. It's really difficult to explain how it is until you've been there, When I arrived there and I finally realized, like, oh, okay, that's how it is. Those are like really like narrow tunnels. You see those ancient masks. I mean, they're like hundreds of years old, and they're really beautiful. I mean, and I was really impressed. But this site is usually not open to the public. It's very fragile. It's really impressive, and that we should show this to a lot of people. There are more impressive sites, but at the same time, these ones, they'll never be seen by anyone outside of the archaeologists and the workers.
Okay, so I think I got a pretty decent map of the tunnel. It was fast. Let's see. It's not finished. It's not processed yet, but we can see the tunnel. And now we're in M71, another site, and I'm gonna try to map those giant masks here.
Last year, Dustin and I were scanning. It was really like deep into the pyramid. It gets really stuffy and really hot really quickly. Dustin was like the one moving the LiDAR. I was just taking notes and I was sweating. He was he was drenched, dehydrated. That would have been a lot easier if we had just a scanner. We could just do this in 5 minutes instead of like 3 hours. That would definitely be useful.
So I start to pick up the tarp, and all of a sudden this huge black snake comes slithering out. And I was like, oh my gosh, jump back. I'm like, oh, there's a snake. And I look back for Dustin, and Dustin had just ran through the tunnel. He was nowhere to be seen.
I didn't exactly, know what to expect beforehand. Like, okay, what's the scale? You have to crawl. You have a lot of dust everywhere. Well, not everything worked as I expected, but we still did some pretty good work, and I got some pretty good results.
So I'm gonna map those masks with a Kinect this time.
Both the Microsoft Kinect and the Google Tango showed a lot of promise in the results that we got. You know, the challenge really that we're trying to solve as well was to try to map every single detail of this mask without missing an angle. You want to go on the top, you want to go on the side, on the bottom, and then you have those holes and all those features that you want to try to get. It's not easy, and it helps a lot to have this real-time feedback on what you do.
Those excavations can be very complex as we dig narrow tunnels following remnants of ancient architecture, and they're very difficult to convey to the public. And the 3D modeling helps us do that, and it helps us visualize what we're doing and makes us really think about where we're going to dig next. So it's valuable both from a technical archaeological standpoint, but also from a sort of public dissemination standpoint as well, and really being able to convey the results of what we're doing here at Els Oats.
The results that we saw this year have been very promising. We've been able to see moderately sized models, but it gives us confidence that this is actually an interesting direction to pursue. There are still challenges, but that it seems that they're within our reach.
After the fact, there's actually visualizing the data and understanding the data and modeling the data. And so, before you get these either crude sketches, or you have to be there, you have to go there, and you have to look at the data there. Now, if you can create these models, then you can use the large screens that we have at Qualcomm Institute, or you can use virtual reality to look at these models. That gives a unique opportunity to people around the world, not just scientists, to actually look at this data and understand what it's like.
I think with the data that we have, we can do pretty good models. We took the data, the 3D models generated by the Google Tango, and we put them in a virtual reality environment, and you could see some people basically having fun going back through these tunnels, but in this office.
It's hard to explain what it's like there, but I think as you can present these models, and if you could sort of do almost like a game where you're walking or crawling through these tunnels, I think that would give people a lot of understanding of what it's like to do archaeology.
What does that look like? It's like rocks, a bunch of rocks. What do you think you're looking at?
Some kind of sculpture.
Some sort of sculpture?
Yeah.
Making technology available at a much lower cost and a much lower barrier of entry is gonna kind of change the way people think about having these models, using these models, what they can do with them. The more people will do this, the more value other people will see in this, and I think it's gonna snowball. I think it's really gonna enable a different way in which they can do archaeology.